So a function, or if we have a function f of x, okay, its inverse, if it exists, is f inverse, or written as f to the 1/2, but they're not the same thing. Okay, so it's written the same way, but that's not the same as 1 over f of x. Okay. But, so if we have our inverse function, such that whenever we have y equals f of x, our inverse function undoes that. So if we do the inverse function on our output, it'll give us back our input. Okay. Two functions are inverses if we compose them and we get back x for both. Okay. The domain of the function must be in the range of the other function, and the opposite, the domain of g has to be in the range of f. Okay. So a function is 1-to-1 on some domain if every value, or if each value of f of x corresponds to exactly one value in d. Okay, so specifically, if we have two output values that are not equal, with their matching input values not equal, then that function's 1-to-1. Okay, we can look at this through the horizontal line test. That's going to be the main way that we'll look at things in this class. But another way to think about them is that you can't have repeated x values. Or sorry, no repeated y values. Okay, so like, for example, if I've got a function like this, okay, anywhere I draw a horizontal line, it's only going to intersect my function once. Okay, whereas if I had a function that looks like this, and I draw a horizontal line, it's going to intersect the graph more than once. Okay, so we'd have a repeated y value. All right, so we can use this to look at the existence of inverse functions. Okay, so if our function is 1-to-1, then it has a unique inverse. Okay, that follows our inverse definition. All right, we can do a concrete example. So we've got a table like here. Okay, so we can do a couple compositions. So if we had like f of f at -1, so it'd be f of -1, which would equal f of -2, because that's what f of -1 is equal to. Okay, then f of -2 is equal to -8. Okay. All right, we could also we can read our inverse functions off of tables. So f inverse of 2 is going to equal 1. Okay, so what we're doing when we're looking at the table is we're looking what output value of 2, okay, and then what's the matching input value? Or another way to think about that is, so because f of 1 is equal to 2. Okay. We could do, if we had f inverse of 6, okay, f inverse of 6 is 2, and then f of 2 is going to give us 6. Okay, so that's an example of the property. So anytime you've got an inverse of a function and you're doing that function composed with its inverse, it's just going to give you back whatever you're inputting in. Okay, you can think of the inverse function as it undoes what the function was doing. All right, now if we want to find the inverse, we can do this a couple different ways. So we'll look at if we're finding the inverse if we're given a graph. Okay. All right, so let's say we've got a function, f of x is equal to the square root of x, and its inverse. Okay, so I can graph these if I'm given f of x. So there's my function f of x. If I were to graph it, this would be my function f inverse of x. Okay, so something to note, a function and its inverse is always symmetric with respect to the line y equal to x. That line y equals to x is that purple line I just drew. Okay, and we can see where our function and its inverse are symmetric across it. Okay, if we're given a function, we can use this to draw the inverse. So let's say we're given a function f of x equals to 2 to the x. Okay, so we know that'll have the point 0, 1. Okay, shaped about like that. And we need a function that's symmetric about this line. So we'll just kind of lay it over. So that'll give us, so this is our original function. Our inverse will then intersect at 1, 0. Okay, we can see where, so our original function had a horizontal asymptote. So our inverse function is going to then have a vertical asymptote. Okay. And one way to think about these is you're swapping the x values and the y values. Okay. And that's whether you're looking at a table or the graph. The inverse, you're swapping the y values and the x values. Okay, if we're going to do this algebraically, so algebraically, we want to just swap all of the x and the y values, in a sense. So to do this, to calculate it algebraically, we'll solve y equals f of x for x. And if necessary, we'll choose the function that corresponds to our given interval. And then we'll interchange x and y, and we write it using our function inverse notation. Okay, so some examples. Let's say we want to find the inverse of j of x here. And this should be a minus. Okay, so the first thing we'll do is we'll rewrite this using y equals 2x over 1 minus x. Okay, then we'll solve for x. So first step is to rewrite. And then solve for x. So we'll multiply over, so we get y times 1 minus x is equal to 2x. Distribute. And then we'll gather all the x terms on the other side. Factor out an x. And divide to get x by itself. Okay, now I'll swap x and y. So we get x over 2 plus x is equal to y. And then our last step will be to rewrite in function or inverse notation. Okay, and all that means is we'll take and rewrite it using j, or whatever the function name is, inverse of x is equal to x over 2 plus x. Okay, so there's our inverse. All right, that one was straightforward. We might have a restricted domain. So in this next example, we're given our function, and we're specifically told that x has to be greater than or equal to 1. So if x is not greater than or equal to 1, then, so something to think about. If x is not greater than or equal to 1, so we have all values, then this wouldn't pass a horizontal line test. Okay, so sometimes in order to make it have an inverse, we'll restrict it. And we solve it almost the same way. So we'll rewrite it. So we've got y equals x minus 1 to the 4th. And we know that x is greater than or equal to 1, which tells us that x minus 1 is greater than or equal to 0. Okay. And then we'll take the 4th root of both sides. Now when we take the 4th root, we get, so we're solving for x. Okay, the 4th root, when we take that, we get a positive and a negative. But because we know that x minus 1 has to be greater than or equal to 0, we have an x minus 1. So we know that this has to be greater than or equal to 0. So we only take the positive. Okay, so take the positive because x minus 1 is greater than or equal to 0. Okay, so we get the 4th root of y is equal to x minus 1. So the 4th root of y is equal to, or 4th root of y plus 1 is equal to x. Now we swap. So we get the 4th root of x plus 1 is equal to y. And then we rewrite one more time. So we get the 4th root of x plus 1 is equal to f inverse of x. All right, so there's our inverses. Okay, we'll continue to talk about inverses. We'll use inverses as the semester goes on.